Today we're going to cover a few examples. Given the graph of f prime, can we sketch f prime prime? And then looking at f prime and f prime prime, can we get a possible sketch of what f could have been? The second derivative is the slope of the first derivative. So I'm going to look for any time we have a slope of 0. Looking at the tangent lines of f prime, it doesn't look like they are ever 0. It approaches very close to 0 once you go that direction. So if I don't have any horizontal tangents, I'm just going to start estimating any tangents that I can. -1, I think I could do an estimate for this. Let's create a slope triangle for the tangent line, and the height is 2, the base is 1. So the slope at the point -1 is 2. So the slope at the point -1 is 2. That's a point on the f prime prime graph. Similarly, since this has some symmetry, I know that the slope of +1 will be -2/1. So same slope, but opposite direction. So 1, -2. Okay, that's a great start. Let's take a look at what is happening as we get closer to 0 from the left. This tangent. I don't know what the slope of that is, but this slope is then the one at -1. As we approach 0 from -1, our y value for f prime prime will be greater. Looking at -1.5, -1.5 perhaps has a slope similar to 1/2. So at -1.5, I will put a point at 1/2. As the x's approach -infinity, our tangent lines are approaching a slope of 0. We are approaching a horizontal tangent, but not quite. Our f prime prime values will approach 0, but not quite. Now, I do see that this graph, f prime, has y-axis symmetry, and so I can estimate that f prime prime will have some type of symmetry. Maybe it will have origin symmetry, but let's see. Testing some of our slopes, if we tried this same one, like 0.75, I believe we would get something like -3. And as we continue to approach x equals 0, from the right, our slopes are getting steeper and steeper, but they are all negative. So they are becoming, so as we approach x equals 0, this branch will be approaching -infinity. As we go to 1.5, looks like our slope is approximately -1/2. So 1.5, I'll go to -1/2. Wow, this does have origin symmetry. Interesting. I have a sketch of f prime prime, and now I'm going to try to create a possible graph of f by first creating some number lines given f prime prime and f prime. First of all, number lines only care about positive or negative values. So when you're creating your number line, make sure you're only caring about when it's above the x-axis or when it's below the x-axis. That's where we get the signs. F prime is above the x-axis from -infinity all the way to 0. It doesn't cross x equals 0. So x equals 0, vertical asymptote here. So it needs to be noted on the f prime number line, but we don't need to write Cn underneath because it's not a critical number. So to the left of x equals 0, we have a completely positive interval, and to the right of x equals 0, we also have a completely positive interval for f prime. F prime gives us the intervals of increasing and decreasing for f. So this will help me to graph f. F prime prime number line, again, cares about when the values are above the x-axis or below. So from -infinity to x equals 0, we have an entirely positive interval on f prime prime, which gives me a positive interval on the f prime prime number line. If 0 was noted on the f prime number line and it was not a critical number, then it absolutely has to be noted on the f prime prime number line. Because if 0 was not a critical number, it was an asymptote. It was a discontinuity in the domain, and a discontinuity in the domain of f will be a discontinuity in the domain of f prime, will be a discontinuity in the domain of f prime prime. The interval to the right of x equals 0 is completely negative on the f prime prime graph. So on the f prime prime number line, the interval from 0 to infinity will be labeled as negative. The f prime prime number line gives me intervals of concavity and possible points of inflection for f. Now let's remember that if the derivative of a vertical asymptote is still a vertical asymptote, the derivative of a vertical tangent gives you a vertical asymptote, and also the derivative of a vertical asymptote, well, since vertical asymptote is not a critical number, it's a discontinuity, then it stays a vertical asymptote. So once a vertical asymptote, always a vertical asymptote. Now, was this a vertical asymptote before it got to f prime? Most likely. Just to visualize, this right here, f prime, is a rational function. F prime prime gives me also a rational function. The derivative of a rational function is another rational function. We know that from doing the quotient rule. The quotient rule involves your answer as a quotient. So f prime is the derivative of some other function. I'm guessing it's probably a rational function, which always has at least one vertical asymptote. To the left of x equals 0, f should be increasing and concave up. Increasing and concave up, and I know it's rational. So there's just my sketch. I'll check later. To the right of 0, the graph of f should be increasing. But to the right of 0, the graph of f is also concave down. A rational function that's increasing, concave down. This is my estimate for what the graph of f could possibly look like. Then I picked an x value of f, where I'm going to draw a tangent and estimate the slope. And I want to see if that matches up with f prime to know if f has the correct amount of vertical stretch or shrink. My estimate here is that if this graph here is f, then f prime, the slope at x equals -3, my guess is that that is 1. Let's check. Is f prime of -3 equal to 1? -3 would be about here. And what is the y value? The y value appears to be 1/5, 1/4. So this green line needs to have a slope that is much closer to 1/4 than to 1. That would be a tangent that looks like this. What that means is that my branch just needs to hug a little closer to the axes. It is not as stretched out as I had originally estimated. So this is too far. We want it to be a little bit closer. Now let's estimate the slope at -3. That looks to be approximately 1/4, which was our estimate over here that we were aiming for. So there we go, we have a possible graph of f. Remember that if they don't give you a starting point, they don't give you any sort of vertical shift, there's absolutely no way to know if this graph has a horizontal asymptote at y equals 0, which is what it looks like, or if it had a horizontal asymptote at y equals 100, and really this graph is just way up there. But if the vertical shift doesn't matter, then I'm going to choose a vertical shift that makes sense to the blank graph that I've been given, and this one makes sense to me. Number 16, we want to again create a possible f prime prime graph and a possible f graph. So I'm going to estimate the slopes of f prime in order to get my f prime prime graph. Are there any times where the slope is 0, where I would have a horizontal tangent? Not quite. There's no horizontal tangent here. If you don't have a horizontal tangent, let's move on to something else. Let's estimate another slope. So I'm going to estimate a slope that is close to 0, 1. What is the slope of the tangent that goes through 1? My estimate for the slope at x equals 1 is approximately 1/4. So at x equals 1, I will graph the y value of 1/4 for the f prime prime graph, which shows the slopes of f prime. Now I will estimate the slope at x equals 0. The slope at x equals 0, 1/3 or 1/4. So the y value would be 1/3 or 1/4. The y value of the f prime prime graph. Let's check -1. What's the slope of this tangent? Ooh, that almost looks like 1/3. So at -1, I am still basically at 1/3. At -2, that tangent is vertical, which means the slope is undefined. So maybe I could see what's between -1 and -2. Like, what's that, -1.5? 2/3. So if -1.5 is the slope of 2/3, we're finally growing a little bit faster. What about -1.75? Ooh, that is giving me a slope similar to +3. As you continue to approach -2 from the right, the slopes of these lines are becoming greater and greater and greater positive numbers. So the graph of f prime prime, as it approaches -2 from the right, will grow to be greater and greater y values, signifying a vertical asymptote for f prime prime. Now I want to know what is happening to the f prime prime graph, or the slopes of f prime, when x is approaching 2, either from the left or from the right. From the left, let's estimate the slope of the tangent at 1.5. At 1.5, it looks like my tangent has a slope of 1/4. That was kind of what we estimated for 1. At 1.75, maybe it's 1/5, I don't know. It really does seem to be approaching 0. So these points are approaching x equals 2, but because f prime of 2 is not differentiable, f prime prime of 2 will not exist. That will be a hole. Now, how did I know that that would be a hole and not a vertical asymptote? A vertical asymptote the points for the y values for 0, 1, and 1.5 were all approaching the x value of 2, and we're approaching the y value of 0. If it's approaching this x value, to get a vertical asymptote, we have to have tangents that are getting steeper and steeper and steeper, meaning tangents whose slopes are approaching positive infinity and negative infinity. This slope is not approaching positive infinity or negative infinity. The slope at x equals 2 is approaching 0. But at x equals 2, the slope does not exist, so it must be a hole. Let's see what the slope is at x equals 3. Oh yes, they've given us a line. So I actually know the slope on the interval 2 to 5. The slope is just 1 because I have a line. The slope at 3 is 1. The slope at 4 is 1. The slope at 5 is 1. The slopes in between are all 1. The slope at 2.5 is still 1. 2.25 is still 1, except the slope at x equals 2 does not exist. To create my f prime and f prime prime number lines, I need to note any breaks in the domain and the positive and negative values. So f prime is positive from -2 on the interval -2 to +2. On the interval 3 to 5, we are also positive above the x-axis. And on the interval 2 to 3, we are below the x-axis. So f prime is positive from -2 to 2, is negative from 2 to 3, and is positive from 3 to 5. Yeah, this number line actually does have endpoints. It only goes from -2 up to 5. The f prime prime number line cares again about if the f prime prime graph is above or below the x-axis. Well, the f prime prime graph is entirely above the x-axis, but there are some breaks in it. So I must note the breaks on our f prime prime number line. There are no changes in sign for f prime prime, which indicates no change in concavity for f. Here's a break in the graph at 2, and then -2 isn't really a breaking point. It's more of like a, we don't go past this, and then 5, we don't go past that. But the entire graph of f prime prime is above the x-axis, meaning all its y values are positive, meaning the f prime prime values are positive in this interval, positive in this interval, so f will be concave up between -2 and 2 and between 2 and 5. F prime gives us intervals of increasing and decreasing for f and possible relative extrema. F will be increasing from -2 to 2. It will be decreasing from 2 to 3 and increasing from 3 to 5. Ooh, that means we have some relative extrema. 2 is a relative max and 3 is a relative min because the signs on either side for the first derivative test are changing. And the function is changing from increasing to decreasing or decreasing to increasing. Now we'll check the f prime prime number line because f prime prime gives us intervals of concavity for f. To the left of 2, so -2 to 2, f will be concave up. And from 2 to 5, f will be concave up. First, I'm going to graph my relative extrema. I have a relative max at 2 and a relative min at 3. And I have to kind of guess a stretch, okay? Are there, 5 y values between the y values of 2 and 3, or is there just one y value? Now, it would be very helpful if I knew a starting point, okay? If I could get some sort of a y value so I could make the rest of the graph match. But they didn't give me a starting point, so I'm going to make one up. If I have a relative max at 2, I'm going to choose its height is at 2, 2. You could choose 2, anything, okay? I just want to give myself a little bit of room above and below. If 2, 2 is my relative maximum, 3, something is my relative minimum. Where do I want that to be? I'm going to make it 3, 1. So I know that we're going to connect these points. I know it's going down from that point, and I know it's going up from that point. But the concavity will also help me. Now I look at the f prime number line again and see the graph of f is increasing from -2 to 2. So from -2 to 2, we should be increasing. We are decreasing from 2 to 3, and we're back to increasing from 3 to 5. So this is a possible sketch, and we're concave up from -2 to 2 and concave up from 2 to 5. We're getting closer to what our graph should look like. Concave up and increasing, and then we are concave up and increasing from -2 to 2. I'm going to test the stretch and see if that seems accurate. What is the slope of the tangent at -1? What do I have here? A slope of 1/2. So my guess, my estimate, is that f prime of -1 is 1/2. Now I go back to f prime. If I plug in -1, what is the y value? Oh, it's greater than 1. It looks like it's 1 1/3 maybe. So 1/2 is too small. This purple tangent line should look more like this pink tangent line. If I'm going to have a tangent line with the slope that the pink one has, then my curve of f needs to be vertically stretched. Okay, that is a slope of about 1. Okay, this looks like a better picture to me. That right there, is that a hole or is that a value? Well, if it were a hole, then it would also have to be a hole on f prime, because a hole is a discontinuity. It's a break in the domain of f. If it's a break in the domain of f, it has to be a break in the domain of f prime. But -2 on f prime has a y value. The y value is 0. So -2 has a tangent with a slope of 0, meaning the slope at x equals -2 does exist since it's 0, and that's why you have a point at -2, 0 on the f prime graph. And this stops at about 5. And that's the end of our review for graphs today.